Hello, everyone. I'm Du Weilin, come from School of Computer Science and Technology on Hue University. Today, I do a presentation on topics of LLM-4 Workflow, an LLM-based automated workflow model generation tool. Currently, workflows are pervasive in software systems where business processes and scientific methods are implemented as workflow models to achieve automated process execution. At present, most workflow tools require users to design workflows either using a low-code approach via script languages or no-code approach via visual editors. Despite the benefit of no-code or low-code workflow automation, creating workflow models requires in-depth domain knowledge and non-trivial workflow modeling skills. However, in the real world, most users may neither possess enough knowledge of the problems they try to solve nor have sufficient experience in software development. Even for domain experts, it is still a challenging job to create valid and executable workflow models. Recently, with significant advances in language comprehension and generative capabilities of large language models, their potential to automate software design and development processes is being extensively explored. This table compares LLM-4 workflow with the most relevant workflow tools. It can be seen that traditional workflow tools often require users to manually perform many steps, whereas our tool demonstrates a more significant advantage in workflow modeling. LLM-4 workflow is based on large language model and the rewrite-retrieve-read retrieval-augmented framework. The process of LLM-4 workflow comprises four main stages. Stage 1, one-time API knowledge base preparation. Stage 2, task extraction and rewriting. Stage 3, API retrieval. And Stage 4, workflow model generation. Stage 1 is one-time API knowledge base preparation. There are a lot of public APIs available on the internet, but the format and quality of API documentation are inconsistent. While it is possible to use these API documentations directly by LLMs, it can lead to low-quality workflow generation and failed workflow execution later. Therefore, it is important for users to pre-build API knowledge bases targeted to their own specific requirements. Before the use of LLM-4 workflow, the API knowledge base only needs to be built once, and then it can be updated with new APIs on demand. Stage 2 is task extraction and rewriting. LLM-4 workflow executes the rewrite step of the rewrite-retrieve-read framework. Workflows are typically represented using directed acyclic graphs, where each node represents a task and each directed edge represents a dependency between tasks. Therefore, our primary goal is to extract a structured task sequence from the user's unstructured workflow description. To enhance retrieval quality and generate accurate workflow models, we rewrite the extracted task sequence into optimized queries. Stage 3 is API retrieval. In this stage, LLM-4 workflow executes the retrieve step of the rewrite-retrieve-read framework. LLM-4 workflow traverses the optimized queries and performs the maximal marginal relevance search in the vector database. After traversal, the results are merged and deduplicated. We can manually remove irrelevant API and customize relevant API that were not retrieved. Stage 4 is workflow model generation. In this stage, LLM-4 workflow executes the read step of the rewrite-retrieve-read framework. The extracted task sequence and the retrieved API are embedded into the LLM's context. LLM then analyzes the task API matching relationships as well as the task dependencies and eventually outputs the workflow DAG. We further convert the workflow DAG model into XML format, which is ready to be executed by real-world workflow systems. Next, I will use a case study combined with a video demonstration to present the entire process of generating a workflow model using LLM-4 workflow. We take the climate dataset mergeviz workflow as an example. This figure illustrates the entire process of generating a workflow model for climate data merging visualization. LLM-4 workflow accepts the workflow description text in natural language format as a user request and undergoes 4 stages of detailed processing to finally output the workflow model in XML format as a response. This workflow was selected from the Kepler Scientific Workflow System and was used to adjust a set of future climate data to match a historical dataset. You can access the workflow via the link provided at the top of the video. Next is a demo video of generating this workflow using LLM4 workflow. First, we enter the LLM4 workflow access address, input the username and password, and then click Login to enter the home page. In Stage 1, we click on the API Knowledge Base menu to pre-build our API knowledge base. We input the document name and description, upload the prepared API description document to complete the creation, and select it from a list to be used as the API knowledge base for the subsequent workflow generation stage. Next, we click on the Workflow Management menu to create a workflow model. By clicking the Prompt button, we send the user request, with the workflow description text already pre-entered in the text area. In Stage 2, we can see that LLM4 workflow has extracted several workflow tasks from the workflow description. Next, set the parameters to rewrite the workflow tasks. In Stage 3, click the Retrieve button to use the rewritten query to retrieve a set of APIs that are relevant to the workflow task from the Build API knowledge base. We can manually remove any irrelevant APIs or click the Add Custom API button to add new APIs. In Stage 4, we embed the task sequences obtained in Stage 2 and the API collections obtained in Stage 3 into the context of the model and parse the task dependencies and task API correspondences to generate a directed acyclic graph of the workflow. Finally, the workflow model is generated based on the directed acyclic graph. The chart shows the task dependencies of this workflow, and the generated workflow model in XML format can be imported to run in a real workflow system. Next, we demonstrate how to run the generated workflow model. Click the Copy Code button to save the workflow model locally. Take the Edge Workflow Edge Computing Environment workflow system as an example. In the system, import the workflow model just now, and configure the Edge Computing Environment parameters to create a workflow. Running this workflow instance allows you to see information such as the runtime, energy consumption, and cost of the workflow. That's all. Thank you.